instance, and online on YouTube, I'll still be in the middle of a sentence, and if something crazy happens, like announcements, or I get off topic, that's on there. It's very, very relaxed, and hopefully we don't get into too much trouble. So we would look at this graph. So here's a graph. We're going to sketch the image of the graph after each translation. What we're going to do is we're going to sketch it on the same one, and since we're doing a number of things on the same one, we're going to use some different colors. If you don't like to graph things on the same thing because it gets full or busy, you can graph them separately. For this unit, at the beginning of the year, I bought a bunch of these little graph paper things. I bought them for $1 each. If you want to buy them for $1 each, they're sticky tabs with graph paper, and you pull them off, and they're sticky on all four sides, and you can slap them into your notes and have a little piece of graph paper. So if you're interested in that, you can come see me. So here we are, part A. We've got this graph. We have no idea what that equation of that graph even is. It's not a graph that we've seen before. It just looks like a bunch of straight lines connect the dot that didn't turn out to be any exciting picture in the end. And they're calling that function g of x. So we want to translate it 4 units to the left. So all I'm going to do is take each of the points that I do. I'm going to do part A in blue. I'm going to take this point and go 4 to the left, 1, 2, 3, 4. Draw a point. Take this one, go 4 to the left, 1, 2, 3, 4. So I take all 4 key points, move all 4 of them 4 to the left, connect the dot, and there we have part A. Now, that part A says, now write the image graph in terms of the function g. This is where you're going to get caught up on a test or a quiz. You're going to see these words, you're going to put up your hand and say, I don't know what this means, and I'm going to have to say, it's a quiz or a test, I can't help you at that time. But that's why you need to pay attention at these things, because it's not hard, but we do have to pay attention when it says image graph in the terms of the function g. What they want to do is take this that was written, y equals g of x, and how would we write that if it had moved 4 units to the left? Would it be inside the function or outside of the function? Inside the function. And would it be plus 4 or minus 4? So this is writing the equation of the image in terms of the function g. Now we want to state for this blue one, domain and range. So it's a little bit of a review. There's 2 different ways you can write domain, and there's 2 different ways that you can write range. I'll write them both every single time so you start to get used to both of them. Remember, domain is your x values and range is your y values. Does anyone have a great way to remember that? Or do you just know it? Do you have a strategy to remember that domain is x values and range is y values? You just know it? Anybody use the D comes before R in the alphabet, so X comes before Y? Ever use that strategy before for memorizing things? I had one student who just called it domain and rangey, put a Y on the end of the word range, and he remembered it all year. He didn't put an X on domain because it just doesn't roll off the domain. It just doesn't roll off the tongue. But he remembered rangey all year. And then he didn't have a problem with remembering that range was the y values and domain was the x values. So what's going to happen here is if our domain is our x values, we can write and notice that our smallest x value is -5, and our largest x value is 2. When you write -5 less than or equal to x less than or equal to 2, that's called set notation for writing domain and range. You can also write domain and range in something called interval notation. Interval notation also goes from the smallest value to the biggest value. And it says, since we start at -5, put a square bracket to say that that value is included. That means the same thing as the equal sign in the less than or equals. And it goes till 2 and ends at 2. And you could write it that way. And that interval means everything between -5 and 2. The range for our graph, again, what's our smallest y value is 2. And our largest y value, it goes up and goes all the way up to 5. So that would be set notation. And interval notation, it starts at 2 and it goes to 5. So you can choose, if a question asks for the domain, you can choose what kind of notation you want to do. But sometimes in multiple choice questions, you have to understand both of them when you're looking at the question. Now for the second one, a translation of 1 unit up. Again, I'll take each of the points and just shift them up 1 unit and draw my graph. When writing that equation in terms of x, we have to ask ourselves, okay, it moved it up and down. That affects the y coordinate. So that's whether that's going to be inside the function or outside of the function. It's going to be outside of the function. And it will just be a +1 outside of the function. For the green graph, the domain is, again, the smallest x value is 2. The largest x value is 6, or in set notation, that would be from 2 to 6. And our range, smallest y value is 3. And our largest y value is 6. To 6. Now one of the things they want you to notice in this question is if we looked at the domain and range of our original graph, which is in red. If I look at my domain from my original graph, it is -2 less than or equal to x less than or equal to 6, or -2 to 6, no, +2, sorry. And if I look at the range of my original graph, the range of my original graph goes from 2 to 5. So one of the things they wanted you to notice is that when we moved our blue graph 4 to the left, that affected only the x values. Do you notice that the range of the blue graph is the same as the range of the original graph? Because if the x values are affected and the y's are not, the range is not going to change because the ranges are y values. But our x values, which were at 2 to 6, now went 4 to the, no, what am I talking about? -1. Yeah, I'm like, whole time here, sorry. I don't know why I had 2 in my head. -1. That changes this. Okay, I need some groans because this is going to be on YouTube for people who just copied but didn't realize that I'd made a mistake. Oh, thank you, thank you. That's appreciative. -1, -1. There we go. Yeah, so the range of our blue graphs were exactly the same. But we noticed that the domain, which started at -1, when it moved 4 to the left, now starts at -5. So you can see the moving 4 to the left in the domain. And same thing with the end of the domain. It ended at 6, but now it ends at 2. And with our green graph, now the domain is staying the same from -1 to 6, but our range is changing, and it got moved up 1. So instead of going from 2 to 5, it's now moved from 3 to 6. So with these examples off to the side, there's space that they give you. Sometimes that space extends to the next page, which isn't necessarily that helpful. But the little bit of space that we have on the side is where we'll write the example. And what you'll see is how much writing you would be required to do on a test or an exam for a question like this, which isn't nearly as much as what they have in the example before. Yeah. In this one, it says state the domain and range for each function. So if you interpreted that as the domain and range of A and B, that would be fine. I did the original one just to show that pattern, but it'll usually be quite explicit on a test or quiz what would be expected. Then what I do once we finish a question is I'll tell you the numbers in the homework that you can do that are similar to this. So because we did example 1 together, you can do questions 4, 5, 6, and 7 in the homework.